Have you ever just stopped, looked at the ground under your feet, and really wondered, how did all of this get here? Not just the city, not the mountains, but all of it, the entire planet. It's a question we've been asking ourselves forever. And today, we're going to go on a journey, a 4.6 billion year journey to be exact, to find the answer.
I mean, look at it. We live on this beautiful, complex world. But if you could rewind the clock, way, way back, you'd find a story that doesn't start with oceans and continents. Nope. It starts with chaos, cosmic dust, and violence on a scale that's almost impossible to imagine. So the real question is, how do you even build a planet from scratch?
All right, so before we had super telescopes and geophysics, what do we have? We had stories. For literally thousands of years, every culture on Earth came up with these deep, incredible myths to explain where they came from. These were our very first theories of creation.
And you know what's so cool? So many of these ancient stories from all over the world share these common ideas. You've got the Mesopotamians, who believe the world emerged from a kind of watery chaos. Then in China, there's the story of the world hatching from a giant cosmic egg. See, these weren't just bedtime stories. This was humanity's first real shot at making sense of the universe.
But then, everything started to change. We began looking up at the sky, not just for answers from the gods, but for hard evidence. And out of that huge shift came the first great scientific idea for how our solar system was made. It was called the Nebular Hypothesis, and it was beautiful in its simplicity.
The core idea is actually pretty simple when you break it down. Everything, the sun, the earth, this whole solar system, it all started as one single massive spinning cloud of gas and dust, a solar nebula. This one idea would become the absolute bedrock of modern planetary science. And, this idea didn't just pop up overnight. It was this whole journey of discovery. It started with a guy named Emanuel Swedenborg. Then the philosopher Immanuel Kant picked it up and ran with it. And finally, a mathematician named Pierre-Simon Laplace gave it some real scientific muscle. You can literally see science piecing the puzzle together over time.
But, of course, in science, nothing's ever that easy. Just when the nebular hypothesis was really catching on, a huge problem popped up. A problem so big it threatened to tear the whole theory apart and sent scientists scrambling for totally different explanations.
Okay, so here it is. It's called the angular momentum problem. Think about an ice skater. When they pull their arms in, they spin way, way faster, right? Well, the physics said that as that giant gas cloud collapsed to form the sun should have ended up spinning incredibly fast. But it doesn't. Our sun spins pretty slowly. All that spin, all that angular momentum, is out with the planets. And that was a huge problem. The math just didn't work. Because of that problem, a new contender entered the ring, the tidal hypothesis. This theory said our solar system didn't form all by itself. No, it suggested that another star passed dangerously close to our young sun, and its gravity literally ripped a huge streamer of hot gas right out of it. And that material is what cooled down and clumped together to form the planets. It was a completely different, much more violent picture of how we got here. And you've got to understand, this argument was part of a much bigger fight in science at the time. On one side, you had the catastrophists, who thought Earth was shaped by sudden, massive, violent events. On the other side were the uniformitarians, who argued that everything happened slowly and gradually, through the same processes we see today. The tidal hypothesis, with its stellar drive-by, that's pure catastrophism. The slow, collapsing cloud of the nebular hypothesis, classic uniformitarianism. So what happened? Well, after decades of debate, scientists figured out a solution to that pesky angular momentum problem. It turns out the young sun's powerful solar wind and magnetic fields acted like a brake, transferring all that spin out to the planets. And with that puzzle piece finally in place, the nebular hypothesis came roaring back. And now, with better tools and new evidence, we can finally paint a really detailed picture of how you actually build a planet. The magic word here is accretion. The absolute best way to think about it is like a snowball rolling downhill. You start with a few tiny little particles that stick together. As that clump gets bigger, its gravity gets a little stronger, so it pulls in more stuff, which makes it even bigger, and its gravity gets even stronger. You see where this is going. And this whole process happens in stages. First, you get these microscopic dust grains sticking together. Then gravity starts to take over, pulling those clumps into bigger, kilometer-sized bodies we call planetesimals. Then comes the really messy part. For millions of years, these planetesimals are just smashing into each other in a chaotic cosmic demolition derby, forming bigger and bigger protoplanets. And finally, a few big winners emerge, having swept up all the competition to become the planets we know today. So as this young Earth is growing, all those collisions, plus heat from decaying radioactive elements, make the whole planet melt. We're talking about a giant ball of molten rock. And because it's liquid, the heaviest stuff, mostly iron, sinks under its own weight, right down to the very center. This incredible event is called the iron catastrophe, and it's how the Earth got its layers and its dense metallic core.
But the story isn't over yet. Nope. Earth's formation had one last, mind-bogglingly violent act to play out, a total cataclysm that would shape our planet's future and give us that beautiful silver disk in our night sky.
You know, for years, scientists had a bunch of ideas about where the moon came from. Maybe a really fast-spinning young Earth just flung a blob of itself out into space, or maybe the moon was just a cosmic wanderer that got snagged by Earth's gravity, or maybe they just formed together. But then, the Apollo astronauts brought back moon rocks, and the chemistry of those rocks proved that all of those theories were wrong.
The evidence from those rocks pointed to something way more violent. Today, the leading theory is the giant impact hypothesis. The idea is that very early on, a planet about the size of Mars, we've nicknamed it Theia, slammed right into the still-forming Earth. And we're not talking a little fender bender. This was a planet-shattering collision. Can you just imagine the sheer energy of that impact? It would have completely vaporized Theia and blasted a huge chunk of Earth's own mantle into space. All that superheated rock, gas, and dust formed a massive ring of debris around our planet. And over time, gravity did its thing, pulling all that rubble together. And from the ashes of that cosmic crash, our moon was born.
So we've built the Earth, we've made the moon, the story's over, right? Well, not quite, because science is always learning, always refining what we know. And right now, our whole picture of what the very earliest Earth was like is going through a massive rewrite.
So, on the left, that's the classic picture of early Earth. It's called the Hadean Eon, basically a hellscape, a world covered in bubbling oceans of magma. But on the right, that's the new view, based on some incredible evidence. A picture of a young Earth that maybe wasn't a hellscape at all, but a much cooler world with continents and liquid water. This whole new idea comes from these tiny, unbelievably tough little crystals called zircons. Some of them found in Australia are over 4 billion years old. They're like tiny time capsules. And their chemistry tells us an amazing story. When they formed in liquid water. That means Earth might have had oceans and been cool enough for life much, much earlier than we ever thought possible. We're talking about a potential billion-year head start for life. So, from ancient myths about cosmic eggs to the chemical analysis of microscopic crystals, our quest to understand where we came from has been one heck of a journey. It's a story written in dust and fire and gravity. And you know what the best part is? The story isn't finished. The next huge discovery could be right around the corner.